Hello, this is Mr. Best. Welcome to Chapter 8, Homework Questions 53 through 59, and this is Day 1 of Lesson 8.1.5. Question 53. The exterior angle of a regular polygon is 20 degrees. Two parts. A. What is the measure of an interior angle of this polygon? Show how you know. Well, if we know the exterior angle is 120 degrees, then we know that the interior angle and the exterior angle are supplementary, so we can take 180 degrees minus 20 degrees so that we find out that the exterior or the interior angle is 160 degrees. Part B, how many sides does this polygon have? Show all your work. A couple different ways you can go about this. If it's a regular polygon, we have, 20 degrees for the exterior, then we know that 360 degrees divided by the exterior angle of 20 degrees will give us 18 sides, because they all have to be the same in terms of the 20 degrees. So if you divide that, you're going to get a total of 18 sides. That's one way to do it. Another way you can do it, if you have your interior angle, is you can use the 160 degrees, because that's your interior angle, is equal to 180 times n minus 2 divided by n, and then you can solve that equation. I'll go ahead and do it so you can see that they will be the same answer. Let's see here, just distributing there, and I'm going to subtract 160 to this side to get 20n. I'm going to add 360 to the other side, and then you can see I'm getting 360 divided by 20 just like I was on that other one, so that gives me n is equal to 18. N represents the number of sides, so n is 18 sides. So at least two ways to approach that problem. Question 54, examine the triangle and the line of reflection at the right. On your paper, trace the triangle and the line of reflection. Then draw the image of the triangle after it is reflected across the line. Verify your reflection is correct by folding your paper along the line of reflection. So that part A is a little bit challenging for me, but I went ahead and showed you below how I reflected it over. Remember the distance between the line of reflection and the vertices here for each of the triangles. That distance should be the same. Same thing here on the bottom, and also from that vertex all the way over as well. So, and then when you fold it, you should be able to see that it is on top of the original. On part B, it wants us to find the perimeter of the image, and then how does it compare with the perimeter of the original figure? Well, this distance is still going to be 11, and this distance is still going to be 17, because the reflection doesn't change the size and shape of it. It should be congruent. So that means those measurements would be the same, so we can use Pythagorean theorem to say 11 squared plus 17 squared is equal to, we'll just call that C. So C squared, 11 squared plus 17 squared would be 410. And then when you take the square root, C will be approximately 20.25 units. It still doesn't answer the question. We need to know the perimeter, so now we can take the three side lengths that we have, the two that were given, the 11 and the 17, and then add the third one that we found to find the perimeter to be approximately, since we approximated that third side length, 48.25 units. And then on to part C, it says find the measure of both angles in the original triangle. Find the measure of both angles in the original triangle. So once again, it doesn't really matter, but we'll call this one angle A and this one angle B. So on here, we're going to use our trig ratios. We can use tangent for both of these, but it just depends on the ratio that you write. So tangent of A is opposite, which would be 11 over adjacent is 17. Where for B, we can still use tangent, but tangent of B, its opposite is 17, and its adjacent is 11. So for each of these, we're going to use our inverse trig to find the angle measure. So that will be for A, and then for B, we'll do the inverse of 17 over 11, and that will give us the measure of angle B. So let's go ahead and plug those in our calculators and see what we get. So for A, we get 32.9 degrees, and then for B, we have 57.1 degrees. And technically, those should add up to 90 degrees because we're approximating. Sometimes it might be off, but looks like this case we're pretty good here. And that didn't write B equals, so let's go back. B is equal to 57.1 degrees. So I think we are good to go. I think we answered all 3 questions on that. Question 55. Find the coordinates of the point at which the diagonals of the parallelogram ABCD intersect if B is at -3, -17, and D is at 15, 59. So parallelogram ABCD, just to kind of get a quick visual, A, B, C, and D. We are looking at the diagonal, especially B to D here, right there. We have B at -3, -17, and D is at 15, 59. I know it doesn't make sense in the picture, it doesn't really matter. Just trying to get a visual to kind of get an idea of what we're supposed to be doing here. It says, find the coordinates of the point at which the diagonals of the parallelogram intersect. So we're looking for where do the diagonals of the parallel intersect if we have point B and point D. Well, we need to know what is true about the diagonals of a parallelogram. And one of the things that we know about the diagonals of a parallelogram is that they bisect each other, which means they must intersect at the midpoint of BD. So these must bisect each other, so that makes those distances the same. So really what we're looking for is the midpoint between those two segments. So a couple ways, once again, that we can do this. The first way, we can find the distance between 15 and -3. So you can actually take 15 and subtract -3. That gives you a total distance of 18. So then half of that is equal to 9. So we can add 9 onto the -3, or we can subtract it from the 15. Doesn't really matter either way. So if we add it to the -3, that would give us 6. If you take 15 minus 9, you get 6 as well. So like I said, it doesn't matter either way. We can do the same thing with the y-coordinate. It's 59 and -17, so 59 minus -17 is equal to 76. Divide that by 2, and that will be 38. And then once again, we can add 38 onto -17, or we can subtract it from 59. And so either way we do that one, we get 21. So that would be the coordinate of the point with which the diagonals of the parallelogram going to intersect. The other way that you can do this is you can take your midpoint is the kind of the average of the x coordinates and the y coordinates. So you could take 15 plus -3 and divide that by 2, and then 59 plus -17 and divide that by 2, and that finds the midpoint right away. So that'd be 12 divided by 2, which is 6, and then 59 minus your 17, which would give you 38 divided by 2. Or no, wait, hold on. Sorry, I was looking back at the other one. Would give you 42. 42 divided by 2 is 21. So, as I said, always lots of different ways to do things. Question 56. Find the area of an equilateral triangle with side length of 20 millimeters. Draw a diagram and show your work. So here's the equilateral triangle. We're going to say this is 20 millimeters on all sides. And we're trying to figure out what the area is. So we can cut this triangle into 2 equal parts. This would be a right triangle. If this is 60 here, then we split it. This would be 30. So we have a 30, 60, 90 triangle. We really need to know what the height of the triangle is. So remember that the hypotenuse is 20, so the short leg would be 10, which these split up into 10 anyway, so we know that. And then the long leg is the square root of 3 times the short leg, or 10 square roots of 3. So that gives us enough information to find the area. So the area is 1/2 times the base, which is 20, times the height, 10 square roots of 3. And so the exact value would be 100 square root of 3 units squared. So if you're looking for the exact value, if we want to approximate it, that's about 173.2. I guess we do have the units on this one, so we can go with millimeters squared for that. Question 57. A hotel in Las Vegas is famous for its large-scale model of the Eiffel Tower. The model, built to scale, is 128 meters tall and 41 meters wide at its base. if the real tower is 324 meters tall, how wide is the base of the Eiffel Tower? So on this one, we could set up a ratio. We can go with the height of the towers over the base. So the first one, we'll use the model. The height was 128 meters to the base being 41. And then we can go for the real tower is 324 meters tall. And it wants to know how wide the base of the real Eiffel Tower is, so we can set that equal to x. And then we can cross multiply. We can multiply both sides by 41x. Once again, just trying to get rid of those denominators. And so once we do that, then we can divide by 128. And then x would be approximately 103.78. And this would be meters. This is the base, so we're looking at meters wide. So once again on that one, we have the height and the width of the model, and looking for the real tower. So we came up, and I guess it says how wide is the base of the real Eiffel Tower. So I can write this out. You know, the base of the real Eiffel Tower is approximately 103.78 meters wide. And so I went ahead and made sure that I did answer the question that was being asked and just didn't leave it as x is approximately. You always want to make sure you are answering the questions. Question 58. For each question below, solve for w. If possible, show all your work. All right, so in part A, we have 5w squared. So we want to use our inverse operations. And the first number we'll get rid of is the 5. That way we isolate the w squared. And that's 17 fifths. And then you can take the square root of both sides to get w, and it's actually the absolute value of w, which is equal to the square root of 17 fifths. So you can leave it like that. You can use your approximation of whatever the square root of 17 fifths is. But remember, it is the absolute value, so there are two values. There's a positive and a negative for that. So w is equal to plus or minus the square root of 17 over 5, or once again, approximately plus or minus 1.84. Part B, we have 5w squared minus 3w minus 17. We might first look at potentially trying to factor this. And once again, you can try that. I'll just let you know it doesn't appear to work. So we're going to move on to our next one, which is we can use quadratic formula completing the square. But since this is not a 1, completing the square is probably not our best bet. So let's go ahead and set up our quadratic formula. A is 5, B is negative 3, and C is negative 17. So x is equal to the opposite of B, so the opposite of negative 3, plus or minus the square root of negative 3 squared minus 4ac all over 2 times a. And then you just start simplifying. So the opposite of negative 3 is positive 3. Then you have underneath the square root 9. And then negative 4 times 5 times negative 17 would be positive 340. And then 2 times 5 is 10. So this would equal 3 plus or minus the square root of 349 divided by 10. So we have two possible answers. 3 minus the square root of 349 over 10. So we'll figure out what that one is. And then x equals 3 plus the square root of 349 divided by 10. And so 3 minus the square root of 349 divided by 10 was approximately negative 1.57. And then if we take 3 plus the square root of 349 divided by 10, we get approximately 2.17. And so those would represent our two solutions. I used x. I just realized technically it was set up for w, but it still works the same way, just wrong variable. All right, and then the last value here, we have 2w squared is equal to negative 3. Similar to a, we're going to divide by 2 and we get w squared is equal to negative 1.5 or negative 3/2, and then you have to take the square root of both sides to get the w by itself, or at least the absolute value, but then we have the square root of negative 1.5. And so on this one, there are no real solutions because we can't take the square root of negative 1.5. So we have no real solutions. Question 59, multiple choice. The triangles below are congruent because of, and then we got to answer which one we think. We have an angle that's congruent, so that's important. We also have this side length right here that they share in common, congruent, so we have that. And then we have two parallel lines. And the parallel lines, we can look at here, there's the transversal, and then here. So our alternate interior angles are congruent, so that would be those two. And so if that's the case, we have angle, which is here, then another angle, which is here, and then the side, which is here. So by angle, angle, side congruency, and then we look at them, we have side, side, angle, hypotenuse, leg, which is for right triangles, side, angle, side. None of them have two angles on here, so we're going to go with E. None of these would represent why the two triangles are congruent.